this computer. There we go. And I still owe you the last ones. It's been crazy because I think I might have gotten COVID. So I'm stuck in my house. Luckily, I'm triple vaccinated, so it's fine. Anyways, so let's talk about object-oriented programming. So we are going to discuss today what are classes, and as part of classes, how we can build them. That's why we need something called a constructor. Okay, so these two go together. Actually, this is a subdivision of what goes inside of those classes. So we're going to analyze the reason why it's important to use classes, because the truth is that, every time that you create a new Python file, like you can kind of creating one entity, right? As a full project that has variables and has attributes. Oh, there it is. Look at that. Drive me crazy. That has functions and has variables. Okay, so why not just packing everything together so that we can just create them on the go? So that's the concept of object-oriented programming. So we're going to create a game called Arkanoid using this approach. And I'm going to show you how this game looks like once it is kind of done. So it's not entirely done. There's always things that can be updated. But this is, generally speaking, how it looks like, right? So it's, some people call it Breakout. It was released for the Atari in around the 80s, something like that. It was the golden era of these low-res video games. So I'm going to show you how to build these elements. And notice how there are three main elements in this game. So there is going to be a bar, there's going to be a ball, and there's going to be a block that has to be broken, okay? Because these three elements are objects on their own, just like the cells that we drew it during Conway's Game of Life. They have to have functions that talk to each other in order to update the whole system when every helper function is called. So that is why we need object-oriented programming. So here is an example from last week. If you were working on your homework or you just remember, we were working on Conway's Game of Life, a very interesting project. So at some point, we were basically trying to update the current grid, the cell grid, by passing it to a helper function that was called the step. That was going to apply the rules from the Game of Life. So this would return another cell grid that we would use in order to render and update, and that would happen forever. Okay, so that is fine. That's a good work, but keep some things in the loop. And the first thing is that we are not really changing a lot of stuff, right? The position of our cells doesn't change. The only thing that changes is the color based on some rules. That's why this is not very cumbersome. This is not really hard to do. But when you have a game that starts looking more complicated with multiple objects, giving one thing in order to return the same thing, just updated, is kind of like redundant. So that's when we need object-oriented programming. Okay, in order to update and render new versions of this grid, we need to return the same object. The signature would be cell grid. I'm just going to call it like that. Produces cell grid. Cell grid is redundant. Okay, so we need a better approach. So classes turned out are a great way to encapsulate our variables, our functions, because the whole point is that the functions that are inside of the class modify the variables. That's the point, right? In order to create a whole entity. So ask yourself these questions. When you are creating your programs, are functions revolving around the same variables over and over again? And the second question is, are your functions calling each other at some point? Excuse me, if that's the case, then it makes sense to create a class. And classes, the traditional way to communicate what classes are is like blueprints, right? If you go to YouTube or any other place, the first thing that they tell you is that they're like blueprints, because this is a template that has two very important things. The first one is going to be attributes. Attributes are the same as variables or constants, depending on how you see them, but they're exclusive for the class. And methods are the same in principle, in heart, to those attributes, except these refer to functions. Okay, but there are also functions that are exclusive for this class. The thing is that if you have a house, you have things that are quantifiable, things that are measurable. Like, for example, how big in area are the floors? How tall is the house? You know, how many years has been around? So you can see some primitives in there. You can see some floats in there in terms of measurements, and you can see some integers in terms of counting the number of years, etc. So those things can get packed, and the architect that actually produces the house takes those information, those data, and then just use it to create instances. So in that way, you can create many houses that they all look in principle the same. Okay, so that is why it is an important, the second most important part of the classes. So classes in Python are built based on constructors and then instantiated the classes. So I'm going to start by showing you what the principle for game Arkanoid is like. So here is the game. Arkanoid this is ours on the left. This is the original Arkanoid on the right. So you have probably seen it. It's very simple. You have just a series, a grid of blocks, and that grid of blocks, you know, gets in touch. At some point, each block gets in touch with the ball, and then it disappears. Different blocks have different attributes, increases the difficulty, but we're not going to worry about that yet. So there are three elements. There is going to be the block, there's going to be the ball, and there is going to be this bar. Okay, so the main character is going to be which of these three? Is it going to be number one, the block? Is it going to be number two, the ball? Or is it going to be number three, the bar? What do you think? Write it in the chat. What is going to be the most important one? Excellent. There we go. Joshua, fast like a thunder. Giving us some answers. Yes. So Justin, do you agree? Excellent. If you agree, because you agree, tell me why. Why is that our main character? Why is that the start of the show? Good. So what do you think is the core difference between this object and the rest? What's the main difference? Because it will be the one moving and the one you control. There you go. Yes, exactly. So this is the one that we control, and this actually we can call an agent. Okay, like in the movie Matrix, this is called an agent. So we control the agent, and it produces certain type of results based on this interaction with the environment. In this scenario, the environment is the size of the screen. Particularly, I'm referring to the walls, because we can really bounce beyond the walls. Then the blocks, because those are solid objects, and then the ball. Okay, so those are going to be the elements that define our environment. So in this game of Arkanoid, what variables do you see in this game? What variables, what things change? So I'm trying to I invite you to think modularly. Like, don't just look at the whole system at once. Look at different components that you know are there. What is going to be a variable in your game? So you have 4 units there, right? 4 objects, well, more instances of one of them, which is the block, the frame, the ball, and the bar. So look at any of this and tell me what you think. What is going to be a variable in this game? And also tell me what object could be modifying. Okay, so we have a ball from Justin. So what do we modify about the ball, Justin? What is a variable in the ball? Movement, angle, and direction. Score. Excellent. X and Y position of the player. Excellent. You're both right. So in ball, variable is direction, and angle. And in the here orgone targets. Oh, the blocks. And blocks. We could call it a live or dead state, right? Excellent, yeah, or height. And then Joshua says the X and Y position of the player. Now, here's an important question. Is Y a constant or a variable for the bar? Okay, we have an answer. and you say constant. Yes, absolutely, right? So the bar doesn't really modify its position in the up and down direction, but the ball definitely does. Now, here is another important question. Here, x in bar. So is the x, the definition for x in the ball, the same one than the definition of x for the bar? Yes or no? What do you think? Justin says no. If the bar is moved after the shot is taken, okay, good. So they could be kind of similar, right? In terms of the range of values that they can take. So for example, the ball can be in position, 3, but the bar can also be in position 3, right? And the same goes for every other place. Now, to the right, this definition might be a little different because the bar has certain width. Certain width, there it is, which means that the longest, well, the farthest we can move it to the right is going to be that distance, that width, and this is going to be the maximum point in X. But the ball that doesn't have that issue, right? It can just bounce around the edge, and the only thing that we need to keep in consideration is how wide that image of the ball is. So there is definitely some differences, but we need to decide if those differences are big enough to justify a new definition of X. So that we're going to need to make that decision. Now, the third one is the data definition in X for the ball the same one as the data definition in X for the blocks? What do you think? If you remember Conway's Game of Life, we couldn't just decide a random, value of X for the cells because they have to be evenly spaced, remember? So this is the same principle. This is the same issue. So we're going to need to keep that in account as well. Okay, excellent. So now what constants do you see in this game? Now, what constants do you see? Okay, the bar, excellent. So, but what about the bar? The background, yes, background. Absolutely. So specifically, what do you mean about the background? What part of the background? The size of the frame, the color, excellent. So background, terrible grammar, there you go. Background color. And then what else? The bar. So Justin, you say the bar. So I'm going to assume that you're referring to the Y position of Y, right? And Y position of bar. Color, excellent. Color and properties of the bar. Let's put a pin on that one. Excellent. Okay, so here are our three objects. What type of information should this object contain? And here I'm asking you to create your pseudo dictionaries. This, I'm going to give you the first one. It's going to need an X position, a Y position, a sprite, and a state, right? Just as you pointed out. You need to define if it is in the game or if it has been, it has been hit already. What else? So let's move to the ball. What type of information should this object contain in terms of your data domain? Okay, it has an X direction, Y direction. What else? A sprite. Absolutely. Yeah, a sprite. And here we're going to include a new type of data definition. There you go. Justin just gave it to us. Is the angle. So angles are kind of like a combination of X and Y, right? So you can see that in this diagram, I'm going to go back. I do that a lot. So here we are. So if you are 0 in X and then you are 1, for example, in Y, then you go straight up. If you are 0.5 in X and 1 in Y, you're going to go a little like bent over, right, to the right. If both values are 1, you're going to get a straight line. So you can see how the direction of the ball changes depending on the values of X and Y. And that is why we're going to call this, like, this can't be X and Y by itself because those are positions, those are coordinates, right? But what we can create is something called dx and dy. And I don't know how used you are to, the mathematical part, but D stands for derivative, which is just a measure of rate, like how much change in X and how much change in Y we're going to apply to this ball. Okay, and these values can also change. Okay, Then the last one is what type of information should the bar object contain? What do you think? What type of information should this object, the bar, contain? Okay, X, Y, and input. X, Y, sprite. Oh, an input. Got it. Yeah, so we can call this direction. You guys are nailing this. Okay, good. So that's exactly what we're going to do. So I'm going to give you a little bit of information for the next couple of sessions. We might run out of time, but I still want you to know about this. So in terms of this direction that you just told me about the input that we decide, there is two main ways to do this. You know, you can set the direction to be equal to a string value that takes, in this case, two values or three values, right? It's going to be go left, it's going to be go right, but also it's going to be stay there or do nothing. Okay, so we can code that with a string. Sprite, what do you mean, Joshua? Sprite and key. So key sounds like a dictionary. What do you mean? Like key down. Oh, interesting. Okay, yeah, keep that thought in mind, because that's going to be the condition that we're going to give the helper function to change the direction to down, up, left, or right. That's good. Okay, so here we go. So that's one way to represent it, but here is another equally good way to represent it that I'm going to invite you to follow from now on. And direction is going to be equal to an array of three values that are each of which is going to be integer. It's binary in nature. Okay, it's going to be like this. So in this case, I'm going to draw down here. So if you have 1, 0, 0, this is equal to left. I am going left. If I have 0, 1, 0, this is equal to nothing. Do nothing, stay there. And finally, if I have 0, 0, 1, well, you can guess it, this is equal to right. And the reason why we write it like this is because this is the way that we can create agents using artificial intelligence when we get to the point when we want our computers to learn to play a game. So this object, the main character in our game is called an agent, okay? And is the one that is going to have these things called states. The states that I just went through, this is going to be the three different states. So we basically feed a neural network, which is an an algorithm in artificial intelligence. We need PyTorch for that. And then we ask it, hey, you know what? Because the algorithm only understands numbers or arrays, it makes sense to ask it, hey, which of these three combinations you think is better to take in the next step of the game, right? Like, for example, your ball is right there, and then you are here. So you ask your model, hey, you know, this is the current condition of the game. Should we go left? Should we go right? Or should we stay in the center to hit that ball? Okay, and that is represented in terms of what combination of numbers, 1, 0, 0, etc., does the agent predict. Okay, so I'm going to show you how this looks like so that it's just not hanging in the air. So I created this snake AI game. So this is what I mean. Give me 1 second. Internet issues might be getting in the middle. But once it runs, what you're going to see is going to be a tiny snake that is trying to learn to play its game and gathering more and more data. So here it is. So there it is. So you have a snake, right? It's a traditional snake game. And my agent, the snake, has a certain number of directions coded in those arrays that it has to follow. And you can see how at the beginning is very brute, is very random behavior. It's not doing really great. But eventually it learns not to bounce against the edges of the walls because it loses. And it learns not to hit itself. It happens in like the 500 generation, but it does happen, right? Now, there are some other algorithms out there that are much better than mine, for sure. But this one does the trick. Okay, so we are going to get into that eventually. That's my hope. So let's go back to our game of Arkanoid. It gets very slow. So Pygame drags some RAM memory. So before we go into the Kahoot to start our game, I'm gonna share this Kahoot just to make some reinforcement to what we just learned. And if you guys have any questions, please let me know. Okay, so I'm gonna share the link in a minute. So give me 1 second. All righty, so let's get that code. Taking some time. Can you guys hear me okay? Please just say yes. If you can hear me okay. I see if Kahoot is laggy, I'm afraid that I myself might be laggy as well. Okay, thank you. Thank you, Joshua. So here is the link. So you can just click on it, or if you want to use another device, you know the drill. Awesome. So let's do this. Okay, question number 1. What type of data type fits this object better? What type of data type fits this object better? Would it be a class? Would it be a function? Excellent. A dictionary. Absolutely. So, and the reason why, as you probably know, is because, we are not including functions in that compound data definition. It's just variables. It's just to unpack them. Okay, double the points. This might be a good one. Why don't we use classes to refer to these blocks? Why don't we use classes? Oh, I think I gave you the answer. Yes. Yeah. Sorry, guys. I know you knew the answer. I just gave it to you. Hope didn't take away the satisfaction. But yes, because we don't have other stuff than, like variables or simpler data definitions than to put in there. The moment that you start putting functions in there, now you need a class, right? I mean, technically, I think there is nothing stopping you to include a function call in a dictionary, but it's super gross. Like people gonna jump over you on Stack Overflow, which is not part of a class. Which of these is not part of a class? Classes have attributes, have methods, have constructors, have initializers. Excellent. So the initializer is just the process of calling the class. It is not part of a class, okay? Attributes, AKA, I think actually there's a question coming about that, but yes, so initializer is just the process of calling the class. It's not part of a class. Okay, what is the range of values that block data definition can take? What is going to be the range of values that the block data definition can take? Take your time on this one. Might be a little tricky. Notice how they all have 0, but is the upper edge the one that we need to take care of? Okay, so I see your message, Justin. Okay, good. So the correct answer is the green one, green square. So it goes from 0 to the size of the screen minus the size of the block, right? Otherwise, you're going to render the block right outside of the screen. That's not something you want. Awesome. Next question. In Conway's Game of Life, what did the render function do? Red triangle applied the rules of the game of life. Blue diamond updated the states of each cell, draw the sprites into the scene, or none of the above. So render, and I think that this is important to note, is that rendering in game development, not only in our course, in general, refers to putting graphics into a scene. That's what rendering means. Okay, so that's why we're following the same format. So it draws the sprites into the screen. Yeah, it happens. Okay, next question. Why do we need dictionaries to group variables together? Why do we need dictionaries to group variables together? Excellent. Yes, so they go together, they belong together, right? It's like a ball. It has attributes that have to be unpacked together. True or false? Classes are like blueprints. Correct. No surprises there. We call classes blueprints because, why? Why do we call them blueprints? We can create as many as we want. Excellent, yeah. They are blue. Okay. Double the points. A constructor is what? What's a constructor in classes? You guys told me you work with classes before. Nice. So there is, yeah, so blue is correct. So a constructor, when you call your house to be created from the template, the first thing that runs is the constructor, and it's going to set up the initial set of attributes, aka variables, that you're going to need to have a consolidated house, you know, a basic house. Okay. True or false? We need classes when the signature of our helper functions is redundant. Remember about the signature and the cell grid? We created, excellent. Yeah, it's true. Yeah, we need them when, you know, the system, the helper function that you call retrieves the same data that you fed into it, right? That's like the classic example of when you need a class. Okay, no third place. Awesome. Okay, good job, guys. I think there was only like one that was difficult. You're doing great. You're doing great. Okay. Okay. So now that we talked about classes, now that we talked about our game design, let's actually start coding. So I'm going to share the live session with you, and you just click on it. So it's going to be in the chat, and you're going to notice that I've already been playing with it for a little bit. So there's going to be some stuff already in there, but that's probably good for us. So Arkanoid is going to be a little complex. Okay, so there's going to be a lot of things that are going to happen and happen quickly. So if you get, you know, like a little confused, please, or you know, like a need to raise some comment, please don't hesitate on doing it. Okay, I see some initiative. That's great. Always encourage. I am your father. Okay, so I am not confusion. Okay, so let's start this. So the first thing that I want you to notice is that I already preloaded the sprites that we're going to be using in this game. So ignore the frog sprite. The second one is called res64. Now, if you look in any of these ones, you're going to see how there is different images, all of them at 64 resolution. Okay, so those are going to be the items that we're going to use. So because you move away from the code, just click on main.py again so that you can come back to the main presentation. Okay, so let's start talking about the X definition. So let's just to be safe, let's create an X definition for the blocks and an X definition for the other games or other objects in the game. Okay, because, and this is going to be very familiar to you, we're going to we're going to be using the same principles that we did when we created Conway's Game of Life. So let's start our data definition. Is going to be X block, and I'm going to call it simply XBL, and it's going to be an integer value. So I want you to think about this as the position in the X coordinate of blocks in the game. Let's start our functions. Let's start our cases. So int X BL minimum is going to be equal to what? So when please fill that up for me. X BL 0 is going to be equal to what? Image loader useful. Good question. Yep. Yep. So we're going to need it in a minute. Yep. Let's work first on the X definitions. So I set up 3 examples. So please help me fill them up. And I'm going to help with the highest. So it's going to be, and if you remember Conway's Game of Life, it was something like the block size multiplied by a number, right? So the number is going to be defined on how many blocks we can fit in our screen. So it seems like we might need a constant that takes the size of the block and gives it to us, right? So let's work on that data definition at the same time. And you're gonna see why in a minute. Data definition block, oh, how do you call it? Block, yeah, block sprite, block SPR, okay? And this one is gonna be block SPR equals, and here is the image loader that you commented, image.load, and is gonna enter a primitive, a string. Interpretate loading an image into Pygame from the system spat. Okay, so we're basically gonna feed into this BL SPR0 is gonna be equal to pygame.image.load, and inside we're gonna give it the address to the first block. Okay, so we're actually gonna load all of the blocks, and because each block is different, we're gonna give a modulo here, and actually gonna simplify BSPR. How about that? BSPR is better, no? BSPR. Okay, so modulo can be one of green, and the colors are there. You look at them in the folder. There is a color green. Let's call it green, reduced to 4 letters. There is green, there is orange, there is red, and there is empty. Okay, so those are going to be the different variables that we have access to. So let's call the first one BSPR GREE. Can someone please fill in the address, the path right here that takes you to that particular image, please? BSPR. Someone else work on orange, please. Or red. There we go. And I'm gonna work on red. Pygame.image.load, and there's gonna be your current direction / resolution 64, which is the name of the folder, / and then I just find the image, which is 64 red. There you go. Okay, so that's how it should look like. Oh, there's one more. It's teal, the teal color. I almost forgot teal. Excellent. And we also need empty. Empty. All right. So now I'm going to create a new constant. And that constant is going to tell me how wide one of the blocks is. So we can take any of the blocks that we have already loaded into Pygame and then just ask Pygame to tell us how wide that block is. So I'm going to create a new constant here. And this is going to be called block W. Okay, it's uppercase, it's a constant. And then I'm going to call BSPR green. And here I'm going to use a method. I'm going to type a dot, and then I'm going to say get width. Pass me the width of this object. Because I'm here already, I don't know if I'm going to use it, but I probably will. I'm going to also load the height. Okay, someone please load the height in that constant. Excellent. Excellent. Good. Now, let's go back to the X block data definition. So now we know what's going to be the size of the block. So in the minimum value, we can say, hey, pass me the width of the block times 0, right? How about in BL0, BL1? Please create some examples. All righty, excellent. Excellent. So now let's see what is going to be the last value for the X in here by printing XBL max. Okay, so let's run this. And if everything works smoothly, we should see some results. Whoops, what happens? Not file resolution 64 block MPNG. What did I do? Okay, so it's called empty. That's what happened. It's not called empty. It's called empty. One letter makes the change, right? What letter makes the difference? There you go. So it's 640. Now notice that the screen, the width to this, the value of the width that I gave to the screen is 650, which means that this block is 10 units long, right? So let's just confirm that by printing block width. And that should give us also the number 10 at some point. Yep. Oh, no, it's 64. What happened? Okay, well, we'll see what happens. Oh, I see what happens. So we need to set up the system so that the number of blocks matches perfectly. In other words, the width should be a multiple of 64. Okay, now I'm going to set here something called resolution. Resolution equals 64 because I might use it. So before I set up the screen, I'm going to say, hey, you know what? I want, how many blocks do you want? Blocks per game, blocks in game, or blocks, yeah, just blocks. And let's say I want 12 blocks of 64. Yeah. So what I'm going to do now is going to be multiply the resolution. Whoever is writing there, please type this: resolution times blocks. Okay, that is going to be the width. So it's going to fit perfectly. So the value for the width in this tuple, which is currently 650, I want you to turn it into an expression that is called resolution times blocks. That one. So you just need to replace it. Excellent. Good stuff. Excellent. Now, we have now our definition for X, and we have now our definition for the size of the screen. So what else? What's next? Well, we need to work on the size. In the position in the Y, variable, right? So it's going to be everything the same except that instead of X is going to be equal to Y. There you go. Very simple, very fast. And instead of a screen 0, it's going to be screen of 1. Now, let's think about what is going to be the minimum value for our blocks. Will it be 0? And also, will it be the block width or the block height? It will be the block height. So let's start replacing those blocks W with block H. Okay, so I'm going to do it for the last one. So you are in charge of modifying the other ones in line 50, 51, and 52. Okay, so instead of block W, it's block H, right? Because this is the height. This is the height of the block, not the width. Okay, I'm going to modify this one, and I'm going to modify this one as well. Now, the second thing that we need to consider is if you look at our illustration of the Arkanoid right here, is right here. So look at it. The blocks don't start right at the very top. They don't. There is a tiny amount of space that is equal to 2 times the height of the blocks, right? And the third one, the third position, is where the first blocks get rendered. The other thing that we need to notice is how many blocks we're adding down. Okay, so we are adding around 10 blocks. So we need to keep that in consideration and say the minimum position of Y is not 0 because the blocks are going to be rendered at the very top. No. I want it to be 3. Okay, this is going to be 4, this is going to be 5, and this one we actually don't need. We need to define how many we want. That is going to be the number that is going to replace this part right here. Okay, I want 10 lines of blocks, so 10 goes in there. Sorry, if I want 8 lines of blocks, 10 goes in there, right? You need to subtract the 2 that are empty spaces. So if you want 10, you add 2, which is 12, etc. So now we have a position in X, a position in Y, and the sprites. So now it's just natural that we might want to create a data definition called block. And that one is going to be called BLK. Let's call it by its color. Nah, let's just call it BLK. Okay, and this is going to be a dictionary that is going to contain an X position with X block. How do you call it? X block. A Y position with Y block. A sprite, which is going to be equal to sprite block. How do we call it? Block SPR. Block SPR. There we go. And as I mentioned before, we're going to add another state. Let's do that later. Let's create this. Someone please start working on the examples. We're going to need around 3 examples, 3 or 4 examples. You know, go nuts. You can create as many as you want. So a block to be updated in the Arkanoid game. There we go. Let's start the first example. BLK 0 equals a dictionary. So I'm just going to copy what I have up there, paste it there. And I'm going to say, well, this is going to be equals to the XBL minimum. Okay, it's going to be sitting right at the very left. And for Y, I'm going to put it right at the very top. I'm going to say YBL minimum. And the sprite is going to be, which one? BSPR, SPR green. There you go. So I want a block that is green sitting at the very top left corner of my screen. That's what it is. So everybody, please make your own examples. And before we do anything else, we're going to render them. Awesome. So let's render them just to see how they look like. Okay, and let's render one. Display.fill, and I want the background to be 40, 40, 40, just because. And then I'm going to call display.bleed and say, oh, BLK0, BLK, let's take BLK1. And this is going to be a sprite. That's the sprite that I want to render. And in a tuple, I'm going to add BLK1 at X position. and BLK1 at Y position. And to make it appear, I'm simply gonna type pygame dot display dot flip. I think it was flip. There you go. Let's see what happens. Let's run this. Oh, someone's writing. Let's wait for that. That's not gonna work because we're typing something. XBL2 is not defined. We didn't define XBL2. Oh, no, we didn't. Okay, let me define one because someone wants to use it. This is going to be 3. Okay, so let's run this. Oh, XBL3 is not defined. I'm going to change it to 2 just for fun. Or yes, thank you. Yes, just create a new example. Yeah. Awesome. So let's times 44. That might be interesting. It's going to be out of the screen for sure. Okay. So what's happening here? There we go. And now we have one of our blocks. Okay, so we put it in BLK1, which is the position 2. And you can see kind of like it matches, right? Like if you can separate the distance from the left corner towards the block in the X direction, there is kind of like 2 blocks in between, right? So it makes sense. There is a comment coming from Justin, so we're going to wait a little bit for that. Now, while we wait, I need to tell you, I can see it on my screen. Oh, yes, that happens sometimes with Replit. Please press Control-R to refresh the page, and you should be able to see it. I don't know why sometimes does that, but I've noticed that if you refresh, everything's fine. Yeah, just let me know when you can see it. Excellent, good. Okay, so that's where we're at. Now, we don't want only one block, right? We want a series of blocks. So just to make sure that we did everything correctly, I'm going to modify BLK3 in the data definition of block to be XBL max. Okay, and for both X and Y, because I want to make sure that I didn't create any block outside of my frame. So if this one shows right at the right corner, we did everything right. Otherwise, we're gonna have we're gonna see something else. The reason why it didn't work is because I didn't update it here. BLK3. So let's run it again. Let's see what happens. Okay, so what happened? So it's there. It's just that the screen is too wide, right? So if you drag it around, we should be able to see it. Where is it? We made a mistake. Okay, so let's see. I'm going to say XBL max is going to be equal to the integer of the screen at 0, block wide minus 1. That should do it. So let's run this again. That's a gigantic screen that we picked. And it should be, nope. Where is our block? BL max. Maybe the problem is why. Yes, there is y. Y is too much. That y is too big, I think. Let's say 1 and see what happens if it renders our block. Nope, the problem is not y, the problem is x. Take a look at the definition at line 46 and tell me if you figure it out. For fun, I'm just gonna say 12 because I want 12 blocks. And I'm gonna run it again. So it should show up at the very right, but it's not. Let's say 11. Oh, there it is. There it is. So with 11, it works. So it's sitting right at the bottom right corner. So the value should be -1. in this data definition. This is what I mean. So it should be the integer of the division of the current screen at position 0 divided by the block width, and is -1. I'm pretty sure of it. Okay, and that's because thank you. Thanks for running it. And it should show up in there. Is it? Oh, yeah, you can see the corner right there, like just the last part. Why? Let me check my notes. Yeah, it is there. It's definitely there, but it's one block bigger than when it was supposed to be. So let me check my data definitions. What I have. With integer at 0 divided that the block size with. No, that's exactly what we have. Oh, well, you know what? Let's put a pin on that and let's keep moving. There is always bugs, so it shouldn't be discouraging. Okay, so what we're gonna do now is to increase the number of blocks in our game. Okay, so we're gonna create a new data definition that is gonna be called block row. And now it should start looking familiar to the game of life, right? Because we're gonna build a whole row. So this is gonna be BLKR equals, and this is a list that is gonna include a list. Well, it's gonna be a list of blocks of arbitrary size. We know that there is a boundary, but we're too lazy to write it down. So this is gonna be a list of blocks covering the whole width of the screen. Let's create them. So BLKR is going to be 0, is going to be equal to what? It's going to be the one at the very left corner. So it's going to be BLK0, right? It's going to be a list that includes BLK0. Then BLKR1 is going to be equal to BLK0 and BLK1. Or we can also write it like this. BLK R0 plus BLK1, right? So they stack together. But at some point, I want you to consider this statement, this comprehension. So I want to create a dictionary whose X value is going to be equal to the block size. Where is it? What do you call it? Block width times X, and a position in Y that is going to be constant. Let's say Y minimum, Y block minimum. And finally, it also needs a sprite. So what sprite should we give it? Well, we have two options. We can give all of the sprites the same color, or we can create a helper function that gives a color for us. So I'm going to opt for the second case, and I'm going to say assign sprite, assign block. Let's just call it assign block. What does it take as an input? Well, it's going to take no arguments, I don't think. Okay, so we're going to define it in a minute, but let me finish the list comprehension. For each X in a range that goes from, and we can see the XBL max, is going to be the size of the screen at position 0 divided by the block width. Okay, so we know that we are going to create enough blocks to at least cover the entire screen. That's fine. So well, let's create our helper function. Let's create our function definition, assign color, assign block. So this one has the signature. What's the signature? So what should we receive? We can say none. What comes out of it? Well, is one sprite out of all of the different, block sprites that we have available. So it's going to be really a Pygame object of type block sprite, a block SPR. Okay, so let's create, the purpose is pick a random color for the block. Let's create a function, assign block. And this one is simply going to use the random module. So let's import the random. Oh, we already did. Yeah, wait to look ahead. That's good for us. So random.choice, and choice takes a list that is going to have all of the different sprites that we loaded in the game. Can someone fill them up in there, please? It's going to be all of the different sprites that we have loaded in our game. The sprites for blocks, that is. Yes, correct. So mostly the variables, right? So go to your data definition. That is called block SPR, that starts on line 20. And we created all of the different examples. So I want you to create a list that uses all of those variable names for green, orange, red, and teal without including empt, because that's a special block that represents no block. Okay, that says, oh, this block has already been hit, so we don't need it anymore, and we change the color. So we're not going to initialize anything with that color. Excellent. So we have orange, we have green, we're missing red and teal. Good. So now we're going to pick a random choice, and we're going to call it choice. Let's call it cheese. It doesn't really matter. And then we're going to return cheese. There it is. So for each block, we're gonna call this this list comprehension, right? We're gonna create a dictionary on the go. So let's see. Let's try to see if what happened here. BLK R2, just to see what's inside. Okay, and oh, it's telling me there might be an error somewhere. Give me 1 second. Let's run this. Let's say for X. Oh, in. I missed the statement, in range. Good, good. We have something, and it's getting printed. There it is, the first row, right? So the important thing to notice here is that X is being updated. Y is not. So Y equals always 78, but X goes from 0, 64, 128, etc., multiples of 64. Just as it's supposed to run. So now that we know it's there, let's actually render it. So while true, notice that this block row is a compound data definition, which means that whenever I need to use one of its elements, I need to unpack them. And the way we unpack them is with a loop. For block, let's call it block in, block row, BLKR2, what do? Well, display.fill, actually display.fill occurs only once. Otherwise, it's gonna refresh the color of the screen and erase everything. But we're gonna say a block, pick the block of the sprite in the current X position and the current Y position. Okay, and finally just flip it. So let's see what happens. Please run it and let's see what comes out of it. Nice, look at that. Nice looking row of tiles. Yay. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, that's what we want. Now let me just check how many we generated, because there might be some that are missing, and I'm suspecting that there are some that are missing there. So I'm just gonna print the length of BLKR2. So notice that even if there are some additional tiles that we can have access to, it really doesn't bother us because, all the boundaries of the screen. No, it worked this time. No idea why when we rendered it before it didn't work. Anyways, So good, good. We have the blocks. Now we need to think about other objects. Okay, but before we do that, we're going to start thinking with object-oriented programming mindset. So the first thing that I'm going to do is, and this is the first time I do this with you guys, so just keep an eye on this. Class definition game, or let's call it game. Okay, game. So, and here I am not going to write a signature. It has a signature, but it doesn't really need it because it changes all the time. So I'm going to say the purpose of this is to create a game of Arkanoid. That's all it does. Now let's call the class template. Let's create the class template. It's going to be, and this is by convention. So I want you to always keep in mind this. The classes always start with capital letters. They're not all capital because they're not constants, but they always start with capital letters. That's the Pythonic way to do it, right? So that other people know that whenever you're calling them, there are classes. Okay, so now we are going to define the constructor. These are called magic functions. It's a type of function that Python takes as a special type of function and treats it in the compiler and assembler in a different way. It's not treated like the other ones. It takes priority. And the function of the constructor is to run the first time, is to run first. You know, and this is similar to Java and not, I don't know, JavaScript, but compile languages like Java use this, a constructor. It's just necessary to specify a class. Notice also that the first argument that I'm passing this class is called self. So self is going to be referring to all of the items of the instance of a class, not the template, right? So that is why we need to specify it almost everywhere. And you see, it's going to get tiring, but over time, it doesn't take a lot of time to just get used to them. And then after the constructor's first argument, we need to pass the arguments that we are actually going to pass the class. And the first one is going to be a screen, which is a constant. We can just drag it directly from the outside world, but it's good to pass it in case we want to call this as a module by other programs, right, that are not part of the main Python document. The other thing is what we're going to pass a list of blocks. And this is, how is it called? BLK, I should have picked better names, guys. I'm sorry. BLKR. Okay. And notice that I'm not adding any numbers to it, which means that this is the part of the code where, you know, this is the main script. So I'm just passing it as an argument. This is not an example. This is the actual use of this part. Then we're going to initialize the variables, the attributes. So I'm going to say self.w is for the width is going to be equal to a screen at 0. Self of h, which is the height, is going to be equal to a screen at 1. Then self of BLKR, the block row, is going to be simply equal to BLKR. Okay, we are just passing as it is because we're going to unpack it. So here we go. We're ready. As far as we know, we can keep updating stuff and adding them to the initializer, but I want you to notice something very interesting. So I'm going to call it now. I'm going to create an instance of this class. So I'm going to comment this below and look what I'm going to do. So this is going to be called Arkanoid. Arcanoid equals game. I'm creating an instance of that game. And here I need to pass the arguments. The first one is going to be the screen. It's just called like that. And the second one is going to be BLK R0. I think was 0 now. What's the last one? R2. Okay, it's the one that covers the entire row. Good. So now in the initializer, just to prove that this is the first thing that runs, I'm going to say print self.width, and it's going to give us the width. Okay. So even though I am not explicitly calling this constructor, the class is going to call it. So look, there it is. So it gives me 768. I'm going to change this and say, yay, I'm born, you know, because that's really what it's doing. I'm born. Okay, so when I run it, notice that the constructor automatically runs whatever is in there, even if I haven't called it. Okay, so now let's create our helper function. So these are going to be our attributes. Remember, variables inside of a class are called attributes. We need to create methods. So the methods are going to be in charge of affecting these local, we'll call it local, like inside of a class attributes to create the game. And the first one we already have. So let's call it render. Let's call it render, just like before. And notice, this is not going to refer, whenever I call it, it's not going to refer to the template, but the instance of this class. That's why I give it the self value. So I'm going to say, hey, you know what? Well, I already have it here. So is display.fill is just like that. It just look like that. It's exactly the same with some minor changes. This is hurting my brain. We'll take a short break, a very short break in a minute. So where was I? Okay, here we are, and this needs an indentation. So first we fill the screen with a color. That doesn't change. It doesn't require anything special. But notice that for block, right there, the for loop for each block in BLK-R2. At this level, we don't have this variable anymore. We didn't pass it to the class, but what we have is a variable, an attribute that does exactly that. That is called BLKR, and we can modify it automatically. So inside of this function, if we decide to erase blocks, they automatically, they are passed automatically or update the list for all of the different functions. So the whole system moves together. So I don't need to return it and then handle it with a new function. No, no, no. If I erase something here, gets erased for all of the for the attribute outside of that function, inside of the class. Okay. So for block, because this is a pointer that we created in this context of the for loop, is a local variable. Therefore, we don't need a self here. We do not. So we're going to call the block with the sprite, block in X, block in Y, and finally just render it. Okay. So now I'm going to modify the code down here. While true, while I am running the game, I want to call that function arcanoid.render. Notice that in this case, I am not passing any list of blocks. I'm just automatically running it. And if everything works well, it should render it. Wow, there it is. Look at that. It's rendering it forever. Okay. So the rendering process should be fast enough so that our eyes doesn't catch this kind of like a tingling, movements. But, for many reasons, it might be not as fast right now. I don't know why, but theoretically, it should look like one single piece. Okay, good. So let's take a very short break. I'm going to give you guys 4 minutes. You can come back at 6:15. Okay, I'm going to get me a refill on my coffee. And I'm going to stop share for a minute. And I'll see you soon. You guys take your time to come back to the session. Don't worry about it. I'm just gonna start sharing my screen again, just to summarize what we have done so far. So we defined the blocks. Basically, that's all what we have done today. And we put them in a list. And then we just created a class to render them. That's what we have done. So we pass this as an argument. So because of the structure of this data, you can imagine that besides here in line 101, besides the list of blocks, we're also going to pass a ball and a bar. Okay. And afterwards. So I'm going to tell you about something called the game manager. So if you're working in Unity, so this is a game that we made for a conservation group that I made for a conservation group in Kids Island in Vancouver, and then is based on Unity. So it's an RPG. You can make it in Pygame as well, but the whole concept is to just I'm gonna sorry, 1 second. I'm gonna okay. So the general idea is that your characters, your player, and the world, the way that it interacts with it is controlled by something called a game manager. The menu, for example, is also embedded in the game manager. And the reason is because, it's easier to debug. You centralize all of the information. Okay, I'll show you the code later for this project if you are interested, but RPGs are particularly good because right now you can imagine that you need a list of sprites to render your game. You need to manage the scenario. You need to manage the camera, the movement in X and Y and the collisions, right? So that's why we need a game manager. Here, we're going to create something called a step. that is going to be analogous to a game manager. But the reason why we call it a step is simply because it's easier to, like just for now, it's just easier to remember. So, or to remember what it does. And the step is going to be in control of all the different things that we need to make in our game. That's why it's the perfect place to start. So let's think about our game. What do we need to do? Well, at first, I need to render the game. That's one thing that we already did. Yay. Okay, then I also need to what? Update the ball, update ball, check for collision, ball collision. Well, let's call it ball block collision. Let's call it ball block collision. Check for ball bar collision. Need to update bar. Oops. I need to update bar, and those are the ones that I can think of. And at some point, I also need to check for edge collision. Okay, and some of these helper functions will be inside of others. I don't know yet, but this is kind of like the main scheme of my game. That's kind of like what I need to do, because okay, so let's start filling them up. So this is going to be equal to just self. But remember, we're referring to the instance of this function, not the one on the template. So that's why we need to precede the self even when we call functions. So this is going to be render. Okay, and notice that I'm not passing any arguments. And just so that you notice, I'm going to create the function definition render here and give it its signature. The signature is none enters, none comes out. Okay, all the updates happen at the level of the class. And I'm going to say interpretate drawing the sprites in the game. That's all it does. Okay, so good. Now let's work on updating a ball. So we need a ball, right? So let's create the ball very quickly. I'm going to go out of the class into my data definitions, and I'm going to say define data def is going to be X ball. Okay. And I'm assuming that this might be the same. Let's just call it X ball. And I'm going to say X BLL. And this is going to be an integer. So let's get the width of the ball as well. So while you guys work on the data definitions, on the example, sorry, of the data definition, position of a ball in the x-axis. There we go. Please work on the examples here where you put the function. Please work on the examples. Okay, this is going to be xBL minimum, just like before. There's going to be xBL maximum. If you know how to make it, go for it. It's basically the same that we did before. And I'm going to create the data definition for the sprite. Ball SPR, and this is going to be ball SPR, and there is only one, so I don't really have to worry about that. So it's going to be the same pygame.image.load image.load, and then the string, the location where this ball is. Interpretate a ball in the Arkanoid. Then BL SPR, there's only one, so it's going to be 0. 64. Oh, res 64. Res 64. And it's called what ball? 64 ball PNG. 64. There you go. Okay, so now it's loaded. Now I'm going to create new constants. That is going to be the ball width. That is going to be the ball height. So if you know how to, please fill them up. And ball max is going to be equal to just the screen at 0 minus ball width. Nice, good. Yep, excellent. And in this case, we need to call with the parentheses because we're actually using the effect of the method. We're not just calling the method itself. So that's why we need the double parentheses. Good, excellent. So now notice something very interesting. In the definition of X for my ball, I am at the very end, I am not multiplying the block size or the size of the ball times, an integer value or whatever. Here, the only limit, because we are not moving the ball by intervals, the only limit is going to be the width. Make sure that the width of the ball is respected and it doesn't get outside of the screen. So that's why it's minus ball width. So the minimum value stays at 0. So let's create some middle, just one, XBO1. It's going to be equal to maybe 30 pixels. Okay. And that's it. So we also need a Y. So let's create Y. If someone wants to help me with Y, that would be great. I'm just going to modify this. There. Y. Y-axis. And in this case, a screen, excellent. Thank you so much. Yes, is the height and ball height. Good. Now, what else do we need? So if we go back to the presentation, we also defined or determined that we need another new data definition that cares for the angle. What angle is our ball moving? So this is going to be called dx. And I'm not going to call it dx ball because no other object has it. So it's going to call dx and it's going to be equal to a float. This is not an integer. This is going to be a float. And because that goes from 0 to 1. An angle in x-axis at which the ball moves. And I'm going to say restricted, but I'm going to put it above just to be consistent, restricted from 0 to 1. Okay, so let's create some examples. Let's say the x0, the x0, yeah, let's call it the x0, is 0.1. And actually, it goes from -1 to 1 because -1 is also a direction, it's going to the left, whereas 1 is going to the right. So that's why it's -1.0. That's a float. So the x1 is going to be equal to 0, 0.0, and the x2 is going to be equal to, let's say, 0.5. Okay, and the x3 equals 1. Okay, those could be our examples. Now, someone help me create the data definition for dx or dy. And it should go in there. Yeah, I'm just going to paste it there. Okay, so feel free to modify it so that it works with y as well. And when you do that, I'm going to create the next data definition, which is going to be the ball. And BLL equals a dictionary that is going to have x as, where is it, x ball, y as y ball, dx as dx, and dy as dy. Now we also need to include the sprite. So I'm just going to include it here, sprite ball. Where is it? Sprite ball SPR. Okay. So here we have our good. Someone's working in the examples. Go for it. Interpret a ball to be updated and rendered in our game. So BLL0 is going to be equal to, yeah, and let's just initialize the values. I'm going to help with the sprite because there's only one, this BLL SPR0. dy can be dy1, for example. And someone needs to update the x. And yeah, let's just update y ball and x ball. XBLL1, for example, here. Yeah, XBLL1. This one should be YBLL1 as well, for example. Okay, so there we go. Now we have a ball, and we can pass this ball to our game. So let's do that right now. I'm going to go to the line 166. And as a third argument, as promised, I'm going to pass the next element, which is going to be the ball. So I'm going to call it BLL without any numbers. Oh, no, sorry, without BLL 0. That one does need the case. And in the initializer, in the constructor, I'm going to specify that I'm passing this argument. And here I am going to call it just BLL. So I'm going to instantiate it. At the moment that I instantiated it, I'm just going to call it that. Is self.bll equals BLL. There we go. Now it's in the system. Now I need to render it first, and then I need to update it. So in the render function, I'm going to say, once you are done rendering the blocks, please render the ball. And it's going to be as simple as saying copying this display.blit, and block, instead of block, we're going to say self, because there is an actual object that we're not create a variable called ball. We're not creating it with inside of the for loop, because there is no for loop. And then we call self.ball at X and self.ball at Y. Self.ball at Y. Okay, and if everything works well, we should be able to see the ball rendered in the game as well. So name never is not defined. Where does it say never? Never. What happened here? Never gonna give you what? That's pretty weird. Okay, so just get rid of that pseudocode, and then let's run this. So let's see what happens. Okay, attribute error. Pygame image has no attribute get with. What? Get with Pygame image. Oh, we need to, got it. So we need to refer to the ball SPR0 here. So instead of this, it's just BLL SPR0. Okay, because we're referring to the object in the class Pygame, not a method. All right, so where is our ball? There is our ball. Look at that. It's at the top left corner. It's sitting right there. Okay, so the next class, we're going to finish our Arkanoid game. We're getting there. We're really close. The heavy part, well, is still to come. It's the fun part too. I enjoy it a lot. Is about updating the different states or interactions between the different elements. Okay, and there's going to be some funny stuff. So there you go. I'm going to stop sharing my screen. And good, I'm still recording. So I'm going to stop the recording.